streaming.
Welcome after a long hiatus. You too. Oh,
Yeah, how's things?
things are great. Smoking along with the code base.
Yeah.
Dealing now with the probably the pinnacle of problems. Announcing, like broadcasting, like new block, new interblock, things like that, right? That's
Oh yeah, how do you announce on a system where
a distributed system.
and also discontinuous in time as well?
Yeah, so there's the two major tools at our disposal are the distributed hash table, which IPFS provides, and also this kind of distributed publisher subscriber message network that comes with IPFS. The quirks around it are that you need to tune for a small number of topics with a large number of different messages as opposed to a large number of topics because the cost of subscription is high. And so just trying to balance out how that should traffic going around the place and it will stay performant for the applications. So that's where I'm at. It's pretty cool. That's like that's kind of at the moment the engine ticks over and it does one block nicely. But when it goes to make the other block, it needs to deal with the announce mechanism. Yeah, I could just shortcut it and be like, only talk to yourself, but like the very next thing to solve would be how do you make it talk to other computers as well. So I just sort of doing that now. And so, yeah, once I have that, then there will be multiple chains.
That would be the cool
talking to
thing.
each other.
Yeah. Because as you were saying, the conversation we had, I think 3 calls back, where there was only one stroke of the cycle.
Yeah. Now that cycle goes indefinitely, but it does not yet do all the required system functions. I've only implemented one system function right now, which is make a new chain. And there was some discussion I was having with Rex about changing the signature of what a reducer function is so that I can actually write all the system functions in this new covenant signature, which makes them shrink a lot in size because a lot of the code base for the system functions, the way I've done them before, was about how to track continuation between, like, for example, deploy. Deploy can have arbitrarily many children in a tree. The initial action cannot resolve until all the lower layers have resolved and rolled back up. Now I needed to do some accounting for tracking who got told to do what, and when their reply comes in and says they're done, is everything done, and all that, because the system part of a chain can't stall, whereas the developer part, like, it can be like, no, I'm waiting for this other thing. Whereas the system part can't stall, otherwise the chain can deadlock. So now it needs to track multiple concurrent threads almost. And so I came up with a nice standard way to do that for both the system and for the developer, and to allow the developer to choose that multi-threaded mode if they want. And it's all sort of the same system all the time, which has meant a huge reduction in the amount of code that I need in the system to handle that asynchronous tracking. And now that I can rewrite the system functions in the exact same language as what a developer would write their covenant in, which means that in the background, I'm handling all of that bookwork at accounting. That shrinks the system functions down a lot too, and makes them fairly trivial in a lot of cases. So fun. That's what I've been doing, and that's why I was able to do that. 9,000 line delete. I did another
that was the last call.
It was another 1,500 line delete yesterday, and heading for another, probably about another 6,000 lines once this rewrite's done, which should be up and running sometime this week, all going well.
How many lines we got, or what's the projected?
I think it's about probably about 7,000 now. I haven't actually run a check on what I've got.
That's small, isn't it? That's small.
It's small, man. It's really small, but it's just really head scratching.
Most people wouldn't realize how how awesome that is. To get,
yeah,
that's
so, I mean, look, there's two ways to solve the problem, right? Like building mountains of code or doing it properly.
Right. That's really awesome, wasn't it? I've spent many hours actually now when I look back at just playing around with the different interactions. But
it's a simplified model of what we're trying to do.
Yeah, and it also has some predictive behavior, which I think is going to be useful. But also some, I think some potentially using it as the detection of the health of a pool. So, say for example, I've got some notes here. Say if a pool sets up and it's got n actors of unknown type, unknown character. So you got the bad actors, good actors, and the grudgers, etc. It should be possible, I think, to use the Nash model or a version of that to be able to say how cooperative a pool is, with the back assumption that a more cooperative pool is going to be more profitable overall. So, for example, and the thing that makes this possible is the QA, because what you need is that event, because it's a round-based model, right? So on the thing, the character puts in a coin, they get 2 out, they get 3 out, they get none out, and so on. That's similar to a QA going, right, you've submitted this for escrow and I'm bouncing it, or you submitted this for escrow and I'm accepting it. Now, the bad actors, by bad actors, it might not be like being evil. It might be that you're playing
a cheat all the time,
right?
And you could be under strict, which is the same as cooperate always,
right?
Or you could be corrupt. You could be corrupt and favor some. You could be biased,
right? And so we've got trigger points, very helpfully for a model for each of those. So say if someone submits something to QA and they reject it, it's an event, which you don't need to know the ins and outs of it. It's just an event. Someone puts in something to QA and they reject it 12 times, for example. Or someone puts it into QA and they go to arbitration for the DPL because they think that the other side is being unreasonable and the QA is being unreasonable. That's another trigger point. So the point being, what we've got, because of the pool mechanism, is we've got a series of events which are discrete events, which you don't need to know the qualitative reason for it. You just need to know what happened, which is very like that Nash model where you've got, you stick in a coin each, and one guy gets 2 coins, one guy gets fuck all. And so it strikes me that it should be possible to actually run that model based on the data of that pool and saying, well, how productive is this pool? And by productive, I would equate that to how cooperative it is. So, if everyone was good actors, or copycats, in terms of the model.
Yeah, I don't think productive is productive can have different meanings. Cooperative is a really good metric.
Right.
And you could
exactly.
you could publish that as part of like an algorithm or a tool that can assess any pool and give you a cooperation score.
Right. And if you were to try and do that with a set of companies, it would be near impossible because they don't have those discrete events. But we've got a number of discrete events.
I honestly think that this is finally in the territory of what the guys at CERN were getting really excited about.
Yeah.
This stream of events that are common across many different ventures that you can then start to make these models on, and derive these indicators that sort of tell you something more than you can ever know about a company.
Right, exactly. And we've got, because the whole thing built on a state machine, we've got those discrete states, which can completely ignore exactly what the topic is. You could be building a widget for a better mousetrap, or the next Facebook. Doesn't matter. We've got those discrete state changes.
Yeah, right. So this is sort of this is getting into the tuning or the optimizing of the Dreamcatcher beyond the mechanism of the Dreamcatcher seems beneficial on its own merits. But to really excel, you need to it can also serve as a base for these advanced analytics, which is a consequence of its standardization and transparency. And the costlessness of the data.
Yeah. Exactly. It's complete costless information that's available to the entire market.
Yeah,
but
so
also
like a second order.
Right. Yeah. You add in that state changes, and the state changes can be used to abstract away what the actual project is. Doesn't matter. The state changes are the thing that would allow some kind of predictive quality, or some kind of way of assessing a pool about whether it's a bunch of good guys.
I really do think that anyone could write a different analyzer to try and detect things about these pools. We should write some basic ones. One of the main ones should be this community spirit metric, where you're like, hey, these are your options on what you could do next.
Yeah.
Because part of what a standard system gives you is like, you don't have like a million paths. You have these 5 choices in front of you. Yeah. That's it. That's the rules of the game. Right. But we can start to say what community means and what goodness means. And you're like, these 2 choices are personally profitable for you. These other 2 choices are profitable to the network, and if you choose them at your loss, the network will recognize that you benefited it.
Yeah. Exactly. And what the thing I got really excited when Rex sent that model over is you could model without looking, without bringing Nash into it. You could model how often people just agree, but you could also say that some kind of cult in California, everyone agrees all the time, and actually they're getting shafted because there's one guy who dictates everything and everyone just does what he says. And that's not
the first place for us to apply it in anger is that securities guardian, where we can detect copycat. Copycat is dangerous.
Yeah.
Because copycat does not carry an innovation in its signal. Yeah. Copycat causes booms and busts.
Right. Exactly, and doesn't take into account the noise. So it's spiky. It moves quickly.
Yeah. It doesn't have a damper. It doesn't sort of recover. It doesn't. There's probably a number of archetypes similar to what have been put into that game, that the behaviors of people actual real people in the dream capture will start to clump around these archetypical behaviors. And so the securities guardian can be set up to model people as these archetypes and say, look, this is what a scammer looks like. This is a signal of a scammer.
Right.
This is, this is what the signal of someone committing securities fraud looks like.
Yeah.
That we can start to discern those things without even understanding the language they're using in their Twitter feed when they talk about the projects. We could just know from their behavior in game what they were actually like.
Yeah, precisely, because you don't need to analyze what they're saying, what they're going backwards and forwards. You just need to record the point of interaction, which is the end. The point where some guy's saying, I can, I'm skilled in this art, and he's just copying and pasting code, trying to get through QA, and QA bouncing it back and going, oh no, I'm going to go to arbitration and so on. That's a pattern. Actually, pools also have a pattern because the pool events are less. There's when something's sold, but that's still a pattern. So because we've got those trigger events, we've got something that's in terms of a network, which I think the CERN guys were really aiming at. But I think they were coming at it from a different point of view. They didn't have those trigger events because they didn't have the guardians, they didn't have the QAs, they didn't have the arbitrators. There was no.
They sort of.
Did they?
They more or less did. It's just that we've got an implementation. They didn't have an implementation. They just knew they needed the events, and they sort of. Yeah. So what I was trying to get at with the diagrams was that your description of the top level of the Dreamcatcher, you compare the degenerate behavior of the current system for each sort of what's the word for it? Actor or
actor is the collective noun for buyer, builder, investor.
Yeah. So for each actor, you're saying your paragraphs talk about the negative aspects of the current system, and then you talk about how the Dreamcatcher can have a positive outcome for them, but there is no way to talk about the overall system except in very fuzzy terms, because you don't have a direct comparison with the Dreamcatcher anywhere. The worker, the builder, has a direct comparison with how he turns up to do work now.
Yeah.
And he's like, okay, I know that one, and we're saying this new one, and he's like, yeah, I can sort of see that. This thing that happens when everyone can see everyone else's behavior all the time, which seems to be one of the key aspects of that game, is like if you could see what everyone else was doing, the game doesn't work the same anymore.
That's what changes everything. Yeah. They call it communication, but, reputation, transparent reputation is the same.
Yeah, and we're trying to actually build that. Plus, we're trying to hopefully, once we get going, juice it with like suggesting who should connect with who based on your independent patterns. It'd be like you're sitting there watching Netflix, and then you get this pop-up saying, did you know that this person has watched the exact same films as you during the whole pandemic? And you're like, you guys are probably going to get along, right? So,
or your girlfriend's going to get along, one or two. Yeah.
That we want to make, but there's no such system, and so I don't think you can give that top-level description without sort of ragging on each section degeneracies, and then talking about the only real whole thing that you can talk about is like what that game does, which is like, hey, the world's kind of fucked. It doesn't say specifically why. It's just like, do you think so? Because it sort of is. I think that's all you got, right? You can only really focus on these degenerate cases.
So let me reflect back to make sure I understand this. So what I was trying to do is to show that the 1604 model has inefficiencies that are largely, you can reflect back to the Adam Smith idea of a perfect market, and it's Rex's link was useful. Actually, I'm going to add in, the salt of that, where is not necessarily everyone acts as their own agent, because you do get community, and you get emergent behavior from groups of people, so everyone's not just a rational economic agent. However, I don't think that changes the main argument, which is the 1604 model has information gradients. Those information gradients inherently reduce the efficiency of the market, and the size of the market. Do you see? I'm gonna on this screen. I'll not share, but what I'm referring to is the is that diagram that I did on the top level. Let me get it up. Where is it? I'll do my local version. No, I'm going to temper bead in your own time.
Sorry, you want me to go to the TemperBead?
Yeah, just
page?
for the stream. I'm going to bring up the diagram. So it's TemperBead top level. This is loading very slowly.
I thought you had awesome internet now.
So did I. Turns out awesome internet with a 50-to-1 contention ratio is not so awesome.
Oh, dude.
Yeah.
That's,
It's the contention that kills it every time. Right. So
is this diagram?
the diagram is on TemperBead top level.
I'm looking at it. Are you looking at the actual published page, or are you looking at the GitHub page?
TemperBead.github.io / top level.
Down there.
Say again?
But there's no diagram.
What?
There's a diagram called Dreamcatcher Flow that appears to have not loaded.
That's very odd. Well, let me.
I'll go to the GitHub page, and then maybe that will let me.
Why is it not? That's very odd. I'm on the public. Well, the public fork, my fork, but the public one.
Yeah, the public fork, right?
Yeah.
Could you perhaps?
It's been published for like a few days now, so it's weird that. Let's see.
I don't know. Maybe it's because it's.
Just for the avoidance, I'm going to send you the exact link that I'm on.
Okay.
In case we're talking about those purposes. Okay. And it's not far into the text. It's like third section, starting. This is where Dreamcatcher comes in.
This is where Dreamcatcher comes in. Yeah. Honestly, it just gives me a broken thing. Anyway, I'll try to fix it on this side if you're telling me it's all good.
Yeah. Aside from the conversation, it's a bit weird that we're looking at the same site and yours is broken, mine's is not. That's weird. Well, anyway.
The image, it was img Dreamcatcher flow.svg.
Yes, from memory. Let me double check that. That sounds about right.
I think, yeah. Okay, I got it.
Oh, yeah.
There's something wrong with how you're linking. I think it might be how. What, you're not in Chrome, are you?
I'm in Opera.
Yeah. You and 7% of the world. So, okay, I got it now.
All right. Right. So the point I was going to ask is your opinion about this feedback cycle, because when we're looking at comparing, as you say, at the gross level against other, well, the 1604 model, why would this be a better way for each to go? So this is at the actor level, not at the individual level.
What is the 1604 model?
Well, the 1604 model,
In the
number one,
diagram.
is not a cycle. It's a flow, and I've not. That's a good point. Actually, I'll do a diagram on the 1604 model, but the 1604 model is essentially